Welcome to Leco Academy. So in this video we're going to handle a question under half-life. Now here the statement says table C 3.2, which is this table, shows the results obtained from the experiment after taking account of background radiation. So the row on top, it shows the count rate, and the row down here, it shows the time. Now the first question they are saying, plot a graph of count rate against time. So to plot the graph, so we are plotting the graph of count rate against time. So what starts, it is going to be on the y-axis, meaning time it will be on the x-axis. Now when plotting the graph, make sure that you cover at least 3/4 of the graph paper. So to plot this one, now if we check the figures that we have, down here we have 0, 30, 60, 90 and 120. The numbers we have, they differ by 30. Now here on top we have 200, 100, 50, 25, 12.5. So to come up with the scale for this one, on the count rate axis, the lowest number, that is 12.5, and the highest number, that is 200. So if we check our graph, when we use 2 centimeter to represent 50 units, our graph will be very small. It won't cover 3/4 of the graph paper. So for this one, we can use 4 centimeter from this point to that point. So from this point to that point, one box represents 2 centimeter. So we are going to cover 4 centimeter to represent 50 units. So from this point to this point here, this is a 50. So from 0 to 50, so 4 centimeter to represent 50 units. So 50 here, we are going to put 100. The numbers they will increase by 50. So 100 here, we put 150, and here we put the 200, which is our last figure. So at least when we use 4 centimeter to represent 50 units, our graph will cover 3/4. Now down here on our time, we are going to use 2 centimeter, which is the distance from this point to that point, to represent 30 units. So this will be 30. Here we have 60, 90. So they will increase by, the numbers increase by 30, 90, and here 120. This is the time measured in minutes. And here we have the count rate measured in counts per minute. Now that we have indicated the figures on our scale, we can plot the first coordinate, that is 0 and 200. So 200 comma 0. So when putting the coordinates, we use a cross. So our 0 is here on time and 200 is here. So where this 0 and 200 they meet, we are going to put a cross. So they meet here. We put a cross. The other coordinate, that is 100 comma 30. So 100 comma 30. So our 100, it is here, and our 30, it is here. So where they meet, so if we follow this line, they are meeting here. So where they meet, we put a cross. The other point, we have 50 comma 60. So 50 comma 60. 50, it is here, this line. 60, it is here. So where they meet, we put a cross. We also have 25 comma 90. 25 comma 90. So 25 is half of 50. So our 25 is here. So this is 25. So it's 25 comma 90, and 90 is here. So where they meet, we put a cross. The last coordinates, that is 12.5 comma 120. So for 120 we know it's here. Now how can we know where 12.5 is? So we said 4 centimeter to represent 50 units. On the count rate axis. Now how about x when it is equal to 12.5 units? We want to know where we can put our 12.5. So we cross multiply, x multiplied by 50. This will be 50x is equal to, so 4 multiplied by 12.5 to give us a 50 over 50, even here over 50. This 50 and this one, they'll cancel. We'll remain with x. 50 into 50, that is 1. So x is equal to 1 centimeter. This means that 1 centimeter will represent 12.5 units. So 1 centimeter, from this point to that point, that is 2 centimeter. Half of this box makes 1 centimeter. So this box, they have 10 lines. If we count from 1 to 5, that's where our 12.5 is. So this is 1, 2, 3, 4, 5. So 12.5 is here. Now, the other coordinate, that was 120. So 120, it is here. Where it is meeting 12.5, we count 1, 2, 3, 4, 5. So that's where our 12.5 is. After coming up with this pattern, we then join the points. So we start from this up to the end. Make sure the curve is smooth. After joining the points, this now becomes our graph. So this is how the graph should look like. So for question 1, we are done. Now the second question here says, from the graph, determine the half-life. So for number 2, Roman numeral 2, we are determining the half-life. So to determine the half-life, if we check here, the highest frequency we have, that is 200. So half of this 200, so this 200, we are going to divide it by 2. So this 2 into 200, it will give us 100. So 100, it is here. So we are going to draw a dotted line where this 100 is. So where it is meeting the curve, where it is touching the curve, we drop the line. And here it is dropping at 30. So our half-life therefore is equal to 30 minutes. This is our half-life, 30 minutes. So for number 2, that is 30 minutes. Roman numeral 3, what fraction we have decayed at 120 minutes? So 120 minutes, so Roman numeral 3, if we collect data, so we have the period which is given to be 120 minutes, half-life which is 30, we have it already, which is 30 minutes. The number of disintegration we don't know, and the formula we know that half-life is equal to period over the number of disintegration. So we have to find the number of disintegration. So we make n the subject of the formula. So here over 1 we cross multiply. This will be hn is equal to t. We divide over h, even the side over h. Our formula therefore becomes n is equal to t over h. Here on t, we are putting 120 minutes. The half-life, that is 30. So this 30 into 120, it will give us 4. Now, when they ask you to find the fraction, so what fraction will have decayed at 120 minutes? Now, having found the number of disintegration, we are going to put this 4 as the power to this half, which is the fraction. So 1 to the power 4, it will give us 1. 2 to the power 4, that is 16. So 2 to the power 4, it means we have to multiply 2 4 times. This that we found, it is the undecayed. To find the decayed, we are going to subtract 1 over 16 from 1. So 1 minus 1 over 16. This now becomes the decayed. Decayed is equal to, so if we punch this, 1 minus 1 over 16, that is 15 over 16. So 15 over 16 becomes the answer. The last question here, a nucleus of uranium 235, which is this, emits one alpha particle to form thorium. Write an equation for this decay. So here, number C, we've been given uranium 235 so this is its nuclide notation. It emits alpha. It emits alpha particle to form thorium. So thorium, it is being represented by Th plus and alpha particle. Alpha particle, it is being denoted with this, which is helium. So here we have 4 and here we have 2. Now, when a particle emits alpha, this number reduces by 4 and also this number down here reduces by 2. 235 minus 4 to give us 231. 92 minus 2, it will be 90. Such that when we add these numbers, it must give us the parent particle. So 231 plus 4, it will give us the same. 90 plus 2, it will give us the same. So this becomes our answer.